Hey guys, it's Alicia, and today we're going to explore how Address Resolution Protocol works. Your computer has two addresses on the internet, a media access control address and an IP address. But with many computers changing IP addresses all the time, how can networks associate various IPs to a single MAC address? Enter ARP, formerly known as Address Resolution Protocol. In this video, we'll define ARP, contrast it with similar networking protocols, explore its various types and use cases, and the risks of using it in your network. But before we get started, I want to let you know that there will be links to more resources in the video's description. And remember, subscribe and ring that bell to get notifications for future helpful content. Now, what is ARP? Address Resolution Protocol, or ARP, is a common way for networks to translate between or resolve a computer's IP address to its physical machine address. Since these two addresses differ in length and format, ARP is essential for allowing computers and other devices to communicate over a network. To truly understand why this is important, however, let's have a quick refresher on these two address types and how they relate to our daily networking models. MAC addresses and IP addresses identify devices on a network in different ways. Here are some of the main differences between the two. Addresses different layers. MAC and IP addresses work at different layers of the OSI model, which describes the various stages data goes through as it's sent between computers. Local versus global scope. MAC addresses are used for identifying different devices on a local scale, such as different computers sharing a network in an office building. IP addresses work more globally, controlling how devices across the internet locate and communicate with each other. Different address formats. Since MAC and IP addresses work on different layers and do different things, they also have different formats. A MAC address has a serial number-like format of 12 digits grouped into pairs and separated by hyphens or colons, while a typical IPv4 address is a 32-bit address grouped into 4 decimal numbers. MAC addresses are permanent. MAC addresses are assigned to a device by the manufacturer as soon as it's built. This address is essentially embedded into the device's network hardware, making it permanent and unchangeable. IP addresses are temporary and are assigned whenever the device connects to a network. As a result, devices can assume any number of different IP addresses over its lifetime. Physical versus logical. A MAC address is also known as a physical address or hardware address, while IP addresses are sometimes, but not as commonly, known as logical addresses, assigned at different times. As mentioned previously, MAC addresses are assigned once at the time of manufacture. IP addresses can then be assigned any number of times afterward for as many times as the device connects to a network. So where does ARP come in? Since every computer has both addresses, there must be some way to associate one with the other so packets are delivered to the right place. This brings us to the core function of ARP, linking a device's MAC address to its ever-changing IP address and vice versa. Let's take a closer look at how exactly this works. ARP maintains an updated list of MAC addresses and their associated IP addresses. This is usually maintained by a gateway or router, essentially any network switch responsible for managing data flow between networks and devices. To make sense of this, let's take a look at this diagram. Here, the host computer on the left is trying to send something to the computer on the right. To successfully send data to this computer, the host computer needs its IP address and MAC address. Thankfully, the host computer already has the computer's IP address. All it needs now is the computer's MAC address, which is where ARP comes in. Network-connected devices and switches, in this case a router, maintain a list of known IP to MAC address translations on their operating systems. This list is known as an ARP cache or ARP table, which requires constant updates to keep up the ever-changing IP addresses. When a computer wants to send something to a specific IP address, it first checks its ARP cache to see if it has a matching MAC address. It sends out request packets for the MAC address if it doesn't. Another core function of ARP is maintaining and purging IP to MAC translations in the ARP cache. Keeping the ARP cache relatively clear isn't just necessary for getting the latest information. It also helps eliminate inaccurate or unused addresses. As we'll see later, purging translations is also necessary for preventing IP addresses from falling into the wrong hands. Entries in an ARP cache can also be either dynamic or static. Dynamic entries are those populated automatically in the way we've already described. However, users can also manually specify static entries that they want to keep permanently. This is useful for persistent network addresses with set IP addresses. If you're even somewhat familiar with networking, you've probably heard of Dynamic Host Configuration Protocol and/or the domain name system. If so, you may also wonder how ARP in networking differs from these similar protocols. These are all different processes. While they may have a few similarities, they all serve different roles in computer networking. Let's take a closer look. DHCP versus ARP. ARP exists largely because IP addresses are always being changed and reassigned on a network. DHCP is responsible for this constant change, being the protocol that configures a dynamic IP address for hosts, hence the name Dynamic Host Configuration Protocol. DHCP also helps avoid conflicts such as multiple computers being assigned the same IP address. DNS versus ARP. Where ARP associates IP and MAC addresses, DNS associates IP addresses and domain names, such as Kinsta.com. All websites rely on web hosting to host their web pages, images, and anything else that comprises them. Like any other network device, web hosting servers have an IP address. Thanks to DNS, however, you don't need to type in a host's IP address to access a website. Instead, you simply type in a URL like www.example.com, and the DNS server fetches the matching IP address so your web browser can request and serve the web pages from the web host. When explaining what is ARP, there are 4 special types: Proxy ARP, Gratuitous ARP, Reverse ARP, and Inverse ARP. Each type presents different use cases, and in some cases, distinct advantages and disadvantages. A proxy ARP is where an ARP-configured switch, such as a router, handles ARP requests from devices and hosts outside its immediate network. The switch sends its own MAC addresses in response, effectively serving as a representative of every host in its network. To clarify, let's take a closer look at this diagram. Here, the green router in the middle serves 2 separate local area networks. Let's say host B wants to send a message to host D. While this would be no problem if host D were on the same local area network, it's unfortunately on a different network. As a result, host B finds itself in a tricky situation. How can it get the MAC address of the host D? Thankfully, the router comes to the rescue. When host B sends an ARP request message to the router steps in and provides its own MAC address in response. With the router's MAC address in hand, host B sends its message to the router, which is now literally acting as a proxy for host B. The router then sends host B's message to host D, the intended recipient. As you might imagine, proxy ARP is extremely common in computer networking, with typical uses including VPN connections and firewalls. However, there are some disadvantages to proxy ARP, most of which stem from improper configurations. One such disadvantage is the increased risk of sending messages to the wrong places, as devices outside of the network might not be aware of the improper configurations when only dealing with a proxy ARP. Proxy ARPs can also serve as vectors for denial of service attacks. A gratuitous ARP is an ARP response that wasn't previously requested. In other words, gratuitous ARP is gratuitous with sending ARP responses, effectively broadcasting its IP to MAC translation to every host or device on the network. It's almost like someone sending a mass email to let everyone know they've updated their contact information. Gratuitous ARP has several useful applications. For one, it's essential for updating ARP caches and mapping, especially when a new device or node joins the network. In the case of a new device, Gratuitous ARP avoids sending and responding to individual ARP requests to every other device on the local network. Ensuring redundancy is another important use for Gratuitous ARP. For example, some redundant networks might use 2 or more routers with the same IP address. When one of these routers fails, the surviving router sends a Gratuitous ARP to inform the network where to send messages. Reverse ARP does exactly what its name suggests. It sends an IP address instead of a MAC address. Why do this at all? Aren't IP addresses already known to host on a network? Not always. Unlikely as it may seem, some hosts don't even know their own IP addresses. This is often the result of a host simply not having the memory or space to store their IP information, making a RARP request necessary for communication. Remember, only MAC addresses are permanently assigned, and as a result, hosts may not know anything beyond their MAC address. Like RARP, Inverse ARP also sends IP addresses instead of MAC addresses. However, unlike RARP, Inverse ARP works exactly the same as traditional ARP, only that it translates MAC addresses to IP addresses rather than IP addresses to MAC addresses. IARP is especially useful for ever-changing IP addresses. Thanks again to DHCP. Here, a host might know the MAC address of another host or router whose IP address has since changed. With only the MAC address in hand, IARP is necessary for the host to get the new IP address and send their message. Kinsta's WordPress hosting can speed up your website by up to 200%, and you'll get 24/7 support from our expert WordPress engineers. We offer 2 months free with any annual plan, a 30-day money-back guarantee, and unlimited free basic migrations from any host. Head over to kinsta.com/plans to get started. Thank you so much for watching. If you found this video helpful, please don't forget to like, subscribe, and hit the notification bell for more tutorials, explainers, and helpful content like this.